Let's have a look at question 7 in this video. So suppose that customers arrive at a drive-through window at an average rate of 3 customers per minute. And this distribution follows a Poisson model. Now, what is the probability that there will be at least 10 arrivals in 1 minute? So recall, what do we do with Poisson probabilities? We're thinking about average rates per an interval of time. So in this case, we have an average of 3 customers per minute. That's the mean of the distribution that we're interested in. 3 customers per minute. Now, with this in mind, we want to know what is the probability that there will be at least 10 customers, 10 arrivals in 1 minute. In other words, at question 7, we're looking for the probability that we have at least 10 arrivals, given that the mean that we're looking for is 3 customers per minute. So we have to use our Poisson distribution over here. This is the table with the values, where we have values at least equals to 10 for the mean equals to 3. So let's see what's that gonna be. If we have a look at the table, we are going to have values when x equals to 10 for the mean equals to 3, so this amount. Then we have the x equals to 11 and x equals to 12. So let's just work out this math real quick and we'll explain the intuition why it is that way. Over here, let's just write the results. That probability is going to equal to 0.0008 plus 0.0002 plus 0.0001. Now, what do we see? We see that the probabilities are diminishing. So, in other words, the probability of having 10 arrivals is this amount, but the probability of having 11 arrivals is less, is 0.0002, and the probability of having 12 arrivals is even less than that, given all of that, given that the average rate is 3 customers per minute. And I hope the intuition makes sense, because the average is actually quite low. On average, we expect 3 people, but then how come can we have 10? It's very unlikely. That's why the probability is so low. And how come can we have 11, which is even more than 10? Well, that probability is even lower, even more unlikely. And the same logic goes for 12. Even more unlikely to have 12 customers, given that on average we only expect 3. That's the intuition with this distribution. And if we calculate it, what do we get? We would get the number of 0.0011. And if you have a look at the answer key, they only say 0.0008, which is false. Hope this makes sense, and we are done.